Hello, a very warm welcome from my side. My name is Kostas Chinarakis. As Communication Officer of DGE-ROLLOUT, it's my honor to guide through this event. DGE-ROLLOUT is an Interreg project of the European Union. Our vision is to foster deep geothermal energy in Northwest Europe, and by doing so, subsequently nurture the region's economic and the well-being of the citizens. We not only want to generate expertise, but also we want to make it available to stakeholders and investors. So therefore, I'm very happy that so many of you joined us today in our webinar series. I'm sure you will take home some useful insights. For this, I'm very happy that I have a competent speaker at my side. Today, it is Timme van Melle. Timme has a high level of expertise on how the energy system is bound on the physical, the legal, the administrative, and the economic ties. In 20 years on the job, he gathered experience in numerous projects on energy trading, energy transition, and energy assessment. He has a deep knowledge of the roles that exist to keep the delivery of energy secure and how players can fulfill these roles, not only in the way of being environmentally sustainable, but also of being financially sustainable. A senior business advisor at the Dutch gas and geothermal company EBN, he is coordinator of two exploration programs, the SCAN program and the program Ultra Deep Geothermal Heat. Both are mapping the geothermal potential of the Netherlands. So I'm very happy to have him here and giving us some insights on the topic. Timme, the floor is yours.
Thank you very much, Costa, for your kind introduction, and very good to be here and to be allowed to say a little bit about the exploration from geothermal that I've had some experience with in the last few years. Um, I first would like to start with saying a little bit about why we're talking about geothermal energy, because it's not just because it's interesting and fun to explore, but also we want to lower the CO2 emissions, lower the use of natural gas. That's at least something we want to do in the Netherlands. And one of the ways to do that is through district heating. And one of the sources for district heating is geothermal heat. And you can see that currently district heatings are largely powered by power plants, waste heat, by waste incineration, waste heat, and general waste heat from industry. But in a renewable world, as we envision it in the future, there will be very little place for those. Um, then biomass is a possibility, but also that, well, there's some public resistance against that. So geothermal is one of the ways to do that that has a large amount of public support and less of the downside of those other ones, most importantly, the CO2 emissions. We see a large potential in geothermal in the Netherlands, 25% of the built environment and up to 50% of greenhouses, horticulture. So this, for us, it's very important to see where this is possible. Now, just to make sure, many of you might be aware of this, but I just want to make sure that I list this for you. What is geothermal heat? Geothermal heat is deep geothermal heat. That's what we're talking about today. So we use a definition of more than 500 meters. You produce hot water from deep layers and you re-inject it. So it is only at the surface for a short amount of time. You take the heat out and you cool it down, and then you bring back the water in the same layer. Um, the emissions are at least 80% less than of compared to natural gas heating, which in itself is already a low emission source. So that's considerable. And we're usually looking for layers from 2 to 3 kilometers depth. We're also looking at more shallow, like I said, 500 to 1,000, and also ultra deep. But generally, this is the depth that's most common. Um, and One of the important things that we're looking for is a layer that can guide the water, that conduct the water easily enough to bring it back slowly but steadily from the injector. So where the water is pushed back into layer, back to the producer. Not too fast, because then you'll cool down your source, but to make sure that the pressure doesn't build up on one side and doesn't lower too much on the other side, there has to be a good connection between the two. Now, what makes geothermal energy so special as a renewable energy source? Well, exploration risk. You have to imagine that if you plan for a wind or a solar project, then you can actually go to the place where you're thinking of. You put down a device to measure solar. I mean, the sun is very easy to forecast. At least it shines every day. Of course, then there's cloud coverage. Wind, you measure for 2 years, 3 years if you have the time, but then at least you're fairly certain what your resource is. You can trust it before you even start thinking about building the actual wind farm. So here you can see that the risk is lowered a lot before you do the actual investment. Now with geothermal energy, unfortunately, um, the drilling that you have to do as an investment is also the only way to actually go to the layer where you're to find out what your actual resource is. So here there's a lot more investment before the risk goes down. You have to imagine it as if you want to build a wind farm, but you can't actually, let's say in Ireland, but you can't actually go to Ireland. You can't talk to the people there. You have to use satellite imagery to decide whether the wind is actually blowing at the location you want to plan your wind farm. You're only allowed to go there after you've made the investment decision. And that's one of the complications that we're talking about today. That's the exploration we're talking about. Now, um, where might these reservoirs be? At the surface, at least our country is pretty flat, but far below, it's actually not so clear cut. And somewhere between all these layers, you can find layers that are sufficiently permeable, sufficiently thick to be feasible as a geothermal reservoir. And one of the things that we'll also be talking about today is not just the subsurface, so what's happening under the ground, but also, of course, the surface, because what you actually want is to deliver heat above these plays, above these layers. And therefore, one of the first steps you should also take is to look at an area and look generally whether there's enough heat demand to be worth exploring. So you're looking for heat that isn't too high in temperature. So geothermal heat generally, well, it's very difficult to find temperatures above 100 degrees Celsius. So generally, you're thinking about the built environment, space heating, maybe some industrial processes, but you really want to look at places where there's a considerable amount of heat to increase the chance that you will actually be able to realize a project. Now, maybe before I move further into the presentation, I'd like to say a little bit beyond what Costa said about who I am. Um, what I am is a renewable energy expert. So I've worked in the renewable energy sector. I've looked at systems. What I'm not is a geologist. Geologists actually really know about what we're just looking at, the subsurface. What does it look like? What can we expect? What kind of rocks? And they're, of course, very important in this exploration. We can't do without them. And what I'm also not is a geophysicist. And a geophysicist is somebody who knows a lot about how to look at the subsurface, how to investigate what the subsurface is. So they provide, let's say, the data that is required for the geologist to determine what we're looking at in the subsurface. Now, in my past 3 years in experience as in the company I now work for, I've moved a little bit towards knowing about the geology, but looking around on the people on the call here, I'm definitely not the one who has the most expertise on this topic. Well, let me first say that I invite anybody who has something to add from a geological point of view, very welcome. But we keep in mind that this webinar is intended for the people that actually aren't experienced yet in exploration for geothermal energy. So really the people who are thinking about how to approach this renewable energy technology and how to make steps towards realizing a project. And also, I would like to invite all of you to any questions you might have, put them in the chat, and then Costa can keep an eye on it. And I'm very happy to answer any questions at any time that might help you, help you to understand better what I'm saying, but also to understand me, to help me understand better what kind of knowledge you're looking for. You can imagine I'm sitting here behind the screen. I can see Costa. I can't really see you, so it's nice to get a bit of feedback about what you're thinking and what you're wondering about. Now, if you want to know about geothermal potential, so the amount of power you can get from a certain layer in the subsurface, there are a couple of things that really matter. It's not the only ones. I've tried to shorten this. There's a lot more playing, but mainly to determine the power, it's important what kind of temperature there is at a certain layer in the subsurface, and what kind of flow you can realize. So here you see a project. You produce the water with a certain heat, you pump it up, then with the heat exchanger you take the heat out and you try to take as much heat out as you can, and then you re-inject the relatively cold water back in the layer, and there it slowly flows back to the producer. To determine the flow, it's important how thick is this layer, because the thicker it is, the more water can flow through it, and also the permeability. And the permeability is the space in the rock where water can be, but it's not just the space, it's also the interconnectivity. And that's sort of, it says something about the ease with which water can flow through a layer like this. And that's a very important element that we'll come back to later. Now, this might be a slightly overwhelming picture, and I can trust you that we're not going to go through all of this, but this is the main sort of flow that I want to discuss with you. And I'd like to highlight a few things, and sort of the order of things is, well, I said, first thing you want to know is whether a layer is sufficiently thick and at the right depth, because the depth says something about the temperature. Generally, the deeper you go, the higher the temperature. That's not always exactly true, but you can be pretty sure that it's going to be pretty warm down there. Then, of course, here is also the question, is it there at all? So, thickness can also be 0. Then once you've established that you have got that layer, then you want to know, is it sufficiently permeable? Can the water actually flow through? Because if it can't, then it's no use to you at all. Well, then by the time you've ascertained that this is all promising, then you really want to make sure whether it's sufficiently hot. Then you really want to look at models to make sure that you get the temperature that you expect. And then finally, before you actually invest, you want to know, well, is it going to produce for a long enough time to pay back the money that you're investing? So you want to make sure that the reservoir is sufficiently big. There's all sorts of calculations you can do by reservoir engineers to make sure that you be able to produce for a long time. Now, I will be focusing on the top two steps in my presentation, but that doesn't mean that the lower ones are less important. It's just that they are more the ones that if you really start to build up a business case, and yes, the slides will be available, then you will really want to start looking at those bottom ones too. But in the first part, you really want to just make sure there's overall heat demand. There's something else I should emphasize in this whole process is that there is always uncertainty in life, general, but that's not the kind of uncertainty I want to talk about. But in this process, you're never quite sure until you've produced the last megawatt hour in your project that it's actually going to happen the way you intend it to go. So part of the decision making is also to know when to move ahead. How much certainty do you need? But you'll never get 100%. So that's a very important thing to keep in mind during this process. Now, this is what I'd like to discuss with you a little bit deeper, and I'll go through these boxes, many of these boxes during this presentation. So this is kind of the table of contents, if you like. Now, within DGE-ROLLOUT, we're working hard on looking together internationally about in the area that we're at, Northwestern Europe. So that contains North Rhine-Westphalia, large part of the Netherlands, Belgium, and the north of France. And our geologists have come together and they've made an overall map of this area that has a lot of information in it. So it has, well, I'll start with the lower one here, information about the subsurface, so exactly the information that I was talking about, but also what kind of heat demand is available and what kind of district heating. So you might be in one of these hotspots, as they're called, and then you're in luck, because that means that already we see this as an interesting area that that is feasible for further geothermal exploration. So there's an extra then you are further ahead in this process. Also, this will this results in other types of information. So there are tools online. I'm sure there are many more than this one. This is one we use in the Netherlands. It's called Thermo-GIS, Geothermal Information System, Geographical Information System. And this tells you about the first high-level estimate for geothermal energy in any place in the Netherlands and soon also outside of the Netherlands. However, it's important to always keep in mind with these tools that there are a lot of assumptions and uncertainty in them that is not representative. They can be quite deterministic. So it might say 0 at a place where actually we don't know, but because the rule is if we don't know, we say 0, then it might be far too pessimistic. On the other hand, it might also take one little bit of knowledge from somewhere in the country and say, we don't know anything about these other places, so we'll just assume that the whole country is like this. So because these tools want to fill in every pixel of the picture, sometimes there are a lot of assumptions, and it gives an indication, but very few exploration geologists would purely look at these tools to determine whether a geothermal development is feasible. Now, what if you're not immediately in one of these hotspot zones? So you start to wonder, is it likely that there's geothermal energy possible in the area I'm at? Well, first, you want to look at existing data. There's a lot of data usually available, and that's not only from geothermal exploration, but also from oil and gas, and just generally resources that are provided by Geological Service, that, well, by governments, from geothermal, from oil and gas, reports about the subsurface. So there's a lot of knowledge already there. Models, geological models, so the way geologists see the subsurface, sometimes even in 3D, where their estimation of where these layers are are often already available, not always, but it's definitely the first place to look, and online applications, as I just showed. And then finally, there's also data. So seismic data, I'll show you a bit of that data, and well data. So places where there have been drillings, and from these drillings there have been findings, and these are often available sometimes online, sometimes not online. You have to go and physically look at them. But this is the first step, because this is available data that is often also publicly available, sometimes not, but often it is. So that's the first thing to look at. Now, unfortunately, it might be that there's some seismic data available. So I'll show you what seismic data is. So this is a sort of through cut of the subsurface. So this is a line, and you're looking at it from the side, like a layer cake. So this would be like cutting through the cake and then seeing what kind of layers are in there. Now, this is a very useful tool, this seismic data, to determine what the depth and the thickness of potential layers are, because a geologist can interpret this and see, oh, well, this must be a certain layer that is interesting for geothermal energy. Lots of sand, which is always good, for example. I don't know, but it could be. However, an important part of seismic data is to use computers for processing. And if you look at this line, this is a line from 1985. At that time, computers were much, much less powerful than they are now. So if you reprocess, then you can see that it improves a lot. So this is based on taking the old field data and using modern computers and modern algorithms to look at that, to use that field data again to get new results. And then if I toggle up and down a few times, you can see that a lot of things get a lot clearer. And this is a very good way to improve the data that you have. This was done by DMT, which is also one of our partners in the Interreg project. Now, to do reprocessing, of course, the data has to be legally accessible, so it has to be available for you. Sometimes it's not public, then you have to maybe ask whether you can have it, or you have to buy it. In the Netherlands, it's generally available for free, it's public, but that's not true in all countries, unfortunately. It has to be available in the sense it's sometimes a physical process of finding literal tapes in warehouses, boxes that you have to unpack, and you have to look at those boxes and see, okay, well, this is the tape. Where's tape number 2? It's missing. Where is it? So we've literally gone around the Netherlands looking for data, and you have to have it all complete and to be able to do this work. And sometimes you also need to digitize it. So you need to take it sometimes from an analog source and digitize it to actually be able to put it in the computer nowadays. The quality, it's still not as good as new acquisition. With the modern ways of requiring new seismic data are much better, but the costs are very different. It's about 35 times cheaper than doing new seismic acquisition, simply because you don't have to do the operations in the field that I'll be discussing a bit later. Now, if all of this is not enough, then you can do new acquisition. That means you go back into the field, and this is a seismic acquisition as we can do it. It's called shot hole, and that means you're going back into the field and you want to find out about layers in the ground. Now, well, how do you do this? You take a tractor and you drill a hole up to 40 meters deep, and then you put a seismic load or small explosive in the ground. And when you set that off, it sets off tremors in the earth, and they reflect on layers in the subsurface. And the way these reflect and are received by the geophones, by the receivers, says something about what the subsurface looks like. So what the processing then does is try to make sense of how all this data comes back at different times with different strengths. and tries to make sense of it and say, okay, well, this must be the explanation in the subsurface for the way it comes back. This can work up to 6 kilometers deep, but of course, the deeper you go, the more difficult it gets. And this makes a 2D profile of the subsurface. Now, another source you can use is a vibro-size truck. Well, here's one of the activities we did as Interreg. So here you see the trucks in the back, and you see here the tool that sits on the ground and that shakes. Can be quite noisy, but that in this way sends those tremors into the ground that are received by the receivers. Now, the considerations for new seismic acquisition is it's much better than reprocessing often. You're completely in control of your own survey design, so the layers you want to look at, where you want to go, but it's much, much costlier. So you have to think about 12 to 20,000 euros per kilometer. So it's quite an investment to find out more about the subsurface. And also it means an operation. You have to go into the field. It's an operational, but also communication. So you'll have to well, talk to a lot of people and get their approval to get access to the land. And that's also an effort in itself. Now, this is an example of some new acquisition we did within the DGE-ROLLOUT project. So here, just across the border from our perspective in the Netherlands, some seismic acquisition that Vito carried out, and here's some of the lines that we carried out as part of Interreg, but also as part of the SCAN project. And you can see they have to be straight lines because of technical reasons. Some also reaching into Germany. Now, with all this data, you hope that you can have a better idea about depth and thickness. And once you got a seismic line, you can ascertain, hopefully, whether it's thick enough and deep enough. And here you see that also you might have a well, so this is going down here, but then the seismic data shows you that actually what you thought was a very thin layer turns out not to be a thin layer at all, but you just happen to be there at a very unfortunate place. So this gives you larger insight in what you can expect in the subsurface. And also here you see that just on a fold, that it's not representative for this layer here. So this is really helpful to ascertain what's really going on down there. And here's another example where it helps you to see very clearly where a layer is and what the top and the base is, and therefore the thickness. So if you've taken this step, if you really think this is it's not there, it's not thick enough, it's not deep enough, then there really isn't much reason to look further. However, once you've ascertained that there is a good layer that's thick enough, then you have to start thinking about permeability. So yes, the layer is there, but can water flow through it? Now that is very hard to see on seismic data, as I've just shown. And that's why you have to drill. So why do we want to drill? Well, we want to start with 2D seismic. That is because you can cover larger areas and you get a better idea over larger areas where the layers are and how thick they are. But you can't be sure because you have to make assumptions about the speed with which the sound travels through these layers to know what the depth is. And once you've drilled a hole, and you can actually measure truly what the depth is. So only then you're absolutely sure how deep and how thick. But also porosity and permeability is something that you can only find out about once you've gone there and if you've taken up a bit of rock and you've measured how much water can actually flow through it. So to find out about that, you really have to go there, and that's why you need a well. And temperature is another element that, as I've said, you're pretty sure that it's pretty hot. usually 30 degrees per kilometer, but it can change from place to place because of the flow of the water. And of course, with the well, you can put a temperature gauge down there, thermometer, and then you know what the temperature is. Other reasons are also around safety and well design. For example, seismic can say something about seismicity risks. It's a very important element for geothermal that we want to make absolutely sure that there's no risk of seismicity. And with a well, you can know a lot more about the actual rock that's down there. And by getting to know the rock, you know a lot more about the risk of seismicity, for example. So many reasons to do drillings. Now, the first thing you want to do is see, are there any drillings nearby? So are there actually somewhere in the layer already drillings? And well, here's an example of the Netherlands. You might recognize this. This is sort of Amsterdam, Utrecht, Nijmegen, for people who are locally known. Um, and you see here an example, an unfortunate example of an area that is has some very big cities in it, but has very little drillings, and the drillings that there are have very little information. They don't have, they're not geothermal projects, um, and generally we know very little about what this layer looks like. Um, and there's another element that not every drilling also has done all the data acquisition. Um, People who tend to, or the companies that tend to drill for production, um, they're not so interested in the layers that they're not actually using as a target. So they're very likely just to go straight through them as fast as they can, not look at them. And by the time they're done, that information is gone. So often also there might be a well, but it might not have the required data from that well that you need to ascertain your layer. So there are a lot of things that you can also have or not have based on drilling. Now, if you don't have any layers, then you can say, okay, well, maybe there's similar layers somewhere else that might say something about the quality of this data. And here you see that in this layer in the north and in this area, there are other layers that have some kind of forecast about what you can expect down there in the layer. But the closer, the better is the general rule. And also in this case, you have to have the data available. And if that's not so, then again, new acquisition, so an exploration drilling. Now, an exploration drilling, we were talking about seismic acquisition, is a fairly costly affair. So you really have to think about at the depth of 2 to 3 kilometers. Of course, it depends on exactly how far you want to go, 5 to 10 million euros. So it's really something, well, that requires an investment. It is, however, important to know that in an area with very little information, it can be used as a so-called play opener. So an unknown layer, as soon as you have a single drilling in a layer, then already the next drilling is de-risked. So you're already far more certain about the next one. So either you find out, no, this is not the place to drill, we should drill somewhere else. Of course, even better if you find out, yes, this is a very good layer, then the fact that you de-risk the next drilling is worth a lot of money. So that's a reason to still do this. And it's also something that we've decided to do within the SCAN program in the Netherlands. And I'll say a little bit about the way we look at these different plays and how we decide where these drillings are going to be. Well, the Netherlands has 12 provinces, so that's schematically this picture. And there's certain layers, so plays as we call them. For example, the Rotliegend, a nice German term for a layer that we have in the Netherlands, is one of the most important plays for geothermal energy in our country, and that covers many provinces. And if you look at part of that, we call it a subplay, and a subplay is an area where we say um, it has sort of similar circumstances in which it came to being. And also it has a similar history, a geological history. So what that means in practice is that a data sample from one these places in this subplay says something about the rest of the subplay. So this is a very important element in our exploration. And we look at these subplays and we say, okay, what do we think have high potential for geothermal energy? Which ones are hopeful? But also what kind of heat demand is above these subplays, so that we can expect it also to be a base for geothermal development. Now there are more than one, and often they also are at different levels, but on top of each other. So what we do is we look at different ones and then we say, okay, well, let's define a search area where we say this is where we want to do drilling so that we can actually pierce through all these layers to find out about them and to find out whether these are actual layers for geothermal development. Now, within one of these search areas, we define the actual location for the drilling. Now, if you've gone through all these steps, then if the layer is sufficiently permeable, then that's good news, because that means you found something that's thick enough, you found something that is at the right depth in your expectation, and you found something that is also has enough permeability to let the water flow through. And that allows you to take a next step. Of course, you're not there yet, and there's some other elements that I also like to talk about that are on this overview. First, a bit more about seismicity. Seismicity is not something to start thinking about if you think you've got a project. It's really something you want to take up from the very start, because it's a very important topic. We believe that geothermal energy is absolutely safe, but of course people have to be informed about that and why we think it's safe, and that is often a very well, it takes time for people to ask the questions they want to have an answer to, and to show that it's safe, and that in the very unlikely event that there's some damage, that there's also an accurate way for them to get compensated. So this is something to really take up from the very start, and it's very closely connected to public support, because generally there's public support for geothermal energy, but once you actually start talking about a specific project, there are always people who want to know about the risks, and you have to be ready for those questions and have the answers ready. Then, of course, we talked about heat demand, and of course, if you start looking at the business case, then you also have to start looking at the service far more in detail. So here's an example of an area near Utrecht in the Netherlands, and there you see a sort of amount of detail where you really start looking at possible locations, distance from houses, connection to roads, but also not only the limitations, but also the feed-in for the district heating network. Because at this phase, you really want to know, where do I need to take it to, and where do I need to take the heat to? And that is one of the challenges within geothermal energy, to make that all fit together. And that becomes far more important once you've looked at an overall play that's more regional, sort of, hundreds of kilometers, to actual project development. That sort of concludes what I wanted to sort of actively share with you. And well, I'd love to hear your questions and comments based on this presentation.